Okay, so this is question 2 of the handout in class that you sent me an email asking to solve. And it's the NEC between A and B. Notice if I had put a load here, or if the question had a capacitor or an inductor that would be between A and B, and it said the capacitor or the inductor is the load, all that I would do is take out the load and call one side A and the other side B, and we would come back to this circuit. So even if I, like on the exam, even if you don't get to the end, know that I am expecting in the end something like this in parallel with the resistor, and I need to find this resistor in here, the Norton resistance, and the IN. Actually, IN is a different circuit. I think you're more interested in RN, so on the exam you're gonna have to use a test source to find this. So if you see a question, you find the Norton equivalent. Questions, usually it's going to be only the Norton resistance. So I'm going to solve this for with the test source method. If you still have questions, or if you have questions about the IN, so you know, we would short A to B and find only that current between A and B, the 50. Actually, I can solve it right now. The 50 ohms would be out, so Vx is 0. This would be 0. And then you find okay, let me just write IN. Short A to B, which gives me this circuit here. Look. I0, 1K, 3 volts. So I0 is 3 milliamps. Just like this, right? So this is 3 volts. The current is in the correct direction. And this I0 is going to be multiplied by 40. So on the other side of the circuit. So you see these are two independent meshes. So it makes this really easy to solve. So IN is minus 40, I0, which is, IN will be minus 120 milliamps. So if I put this sign going that way, this is going to be minus 120, or you can put the sign going down and call this plus 120. I'm sorry that it's so dark here. I don't know if I can make it much better than this. Okay, so now let's try using a test source. The first step is turning independent off. So now I have only these two. 0.3 Vx. And I'm not going that way, and this is 1K. So I turned the 3 volts off, which means it's shorted. But I still have the other side of this. And this is 40 I0, and this is Vx, and this is 50 ohms. So I can, for example, put a 1 volt power supply here. Sorry about this encroaching on each other here. So if I put 1 volt on there, all of a sudden Vx equals 1 volt. And I'm interested in this current here, Ix. So if Ix is, actually I don't know Ix, but if Vx is 1 volt, the I50 will be Vx, I hope I'm recording this, divided by 50. Which is 1 volt divided by 50 is like 20 milliamps. So that's that current. Now I still need to find this I naught here, because what happens is if I do KCL on node A, so my end game here will be KCL on A, which will be 40 I naught plus 20 milli plus Ix equals 0, or 0 equals all of that. So I know that Ix will be minus 20 milli minus 40 I naught. So now we need to find I naught. So let's go on this side of the circuit to find I naught. So watch. I can do KVL, for example. Now I know Vx. Vx is 1, so I know this is 0.3 volts. Actually, I don't even need to do KVL. So this is 0.3 volts because Vx is 1 volt. 0.3 Vx is 0.3 volts. So I naught will be 0 minus 0.3 divided by 1K. This is Ohm's law. Actually, everything here is Ohm's, I think. So I naught is minus 0.3 milliamps. Finally, Ix will be minus 20 milli minus 40 times 0.3. Minus is plus. 4 times 3 is 12. Ix is minus 8 milliamps. This is only the step 3, and I understand maybe people who haven't done very well on the first exam, you're gonna get credits on the second exam for having practiced nodal, mesh, KCL, KVL, ohms like this. So as you see here, it was like KCL in Ohm's law. Now finally, step 4. This here was step 3, solving the circuit. Step 1 was turning this off. Step 2 is adding this 1 volt. Step 3 is solving. Whoopsie. This is IN. I don't want to put that there. Step 4 is the resistance is the voltage that I applied. So V test divided by Ix. I had 1. Ix is minus 8. Actually, it's the absolute value of this. So 1 divided by 8 milli is like 125 ohms, maybe? Something like this. So Rn is 125 ohms. And for that second part of that question is for max power transfer, we do the load resistance to be the same as the Norton resistance. Then the load would be 125 ohms. I hope that answers that question. Question 2 on the handout.